slope fields are a graphical representation of all the possible solutions to a differential equation. So let's remember, a differential equation is our first derivative, our slope, the slope of a function. So what we're doing is we're plotting all of the slopes is really what we're doing. And we have infinite number of solutions to a differential equation. And let's think about why that is. So why do we have infinite solutions to a differential equation? Well, if I rewrite this, that's dy equals x minus 1 dx. We take the integral of both sides. That gives me a y equals antiderivative of x is 1/2 x squared minus x plus c. I have a quadratic that's shifted up and down infinite ways. There's infinite possibilities for C. Now what we're going to do is we are actually going to take that same differential equation and we're going to graph it and see what happens. Okay, so what we're going to do is take each point and compute the slope at each point. Some people find it helpful to make a table for each point. So I'm going to do that. I'm going to take each point. So I've got -2, 3. -2, 3. So the slope at -2, 3 is going to be -2 minus 1. That's a -3. Then I'll go across to -1, 3. -1 minus 1 is -2. Then let's go 0, 3. 0 minus 1 is -1. Then I have 1, 3. 1 minus 1 is 0. 2, 3. 2 minus 1 is 1. Now, I could go to the next row and do -2, 2, but notice since this depends on x only, all of the points that have an x of -2 are going to have the same slope. All the points that have a x of -1 are going to have the same slope. All the points that have a, and so forth. So let's do the easy one first. The ones with the 0 slope. Every point that has an x value of 1 is going to have a 0 slope. It's going to be a horizontal line. Joot, 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 joot. The next easy ones are the slope of 1. So the way I do it is I kind of think about, well, up 1 over 1. It would be kind of going straight diagonal like that. From this point to this point, so it'd be diagonal, perfect diagonal. Perfect diagonal. Up 1 over 1, up 1 over 1. And so all of these would be parallel. -1 be going down 1, right 1, so be kind of pointed to that point, pointed to that point, pointed to the point below it, pointed there, so it's a perfect diagonal. Now, a -2 slope would be going down 2 over 1. So I'm looking to go there. So it'd be, if I was connecting the dots, I would go all the way to the 1. So this one's going to be going like that. It's pointing to the 1 if I kept going with the point, with the line. So I'm looking to go all the way there, looking to go there, looking to go there, looking to go there if I kept going. If I had a pencil, I would actually draw the line, then erase it. That would have been so smart if I brought a pencil. Now this one's going to go down 3 over 1. So 1, 2, 3 over 1. So I'm looking, like if I was connecting the dots, it would go from this point down to there. So from this point all the way down to there. So it's meow, 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 meow. Now notice what we have here. If I connect the dots, I have a whole bunch of parabolas. Parabola. With a vertex along x equals 1. They're just up and down from each other. If we connected the segments, we'd get parabolas. Okay. Next one. Okay, so x minus y. Oh, this one has x and y in it. Okay, so I'm going to make a little table. Let's start with, I like to start with -2, comma 3. That'd be -2 minus 3. That's a -5 for my slope. Then let's go down. So -2, 2 be -4. -2, 1 would be -3. -2, 0 be -2. -2, -1 be -1. Notice that there's a pattern here. -2, -2 would be 0. Okay, that's as far as we go. Now the next row is going to be -1, 3. That's going to be -4. -1, 2. -1, 1. -1, 0. -1. -1. That's going to be 0. Okay, so -1, -2 would be 1. Really noticing a pattern. 0, 3 would be a -3. 0, 2 would be a -2. 0, 1 would be a -1. 0, 0 would be a 0. 0, -1 would be a +1. 0, -2 would be a +2. I think we've got enough to have a pattern. Let's start with the 0 column. This was 0. This is a +1. Goes up like that. This would be a +2. This one was a -1, -2, and a -3. Now, from what I noticed, -1, -1 also had a 0 slope. This one had a 0 slope. If this pattern continues, this one would have a 0 slope, and this one have a 0 slope. This had a +1 slope, so this one would have a +1 slope, and this one would have a +1. Oh. This one had a -1 slope. This one has a -1, -1, -1, -1. -2, -2. So all of these will be parallel. +2, +2, +2. 3, 3. More steep, more steep, more steep, more steep, more steep, more steep. Ooh, that's a pretty one. And if you have trouble eyeballing these, if you wanted to, like, take another piece of paper or fold your paper over and kind of make it into a ruler, you know, like 1 to 1, up 2 over 1, and so you can make your lines a little bit straighter. That'd be fine too. Okay. Their favorite way of asking these also is in the multiple choice. Here's the slope field. Which of these could be it? Now, one way to look at these is to note when there's 0. So you would pick maybe a point where the slope is 0, and find all of the values that get it 0. So here I know that the slope is going to be 0 when x is 0 or when y is 0. But that's not always true, because here x is 0 and y is 1. Well, that should be a 0. So this one doesn't work. Okay. If I factor this is y times x minus 1. This will be 0 when y is 0 and when x is positive 1. That doesn't work. This one would be 0 when y is 0 and when x is negative 1. That works. This one is when x is 0 and when y is negative 1. Oh, this is it. You could also pick random points, plug them in, see what you get. Okay. They also like to ask these on free response, where they give you the field, give you the equation, ask you to fill it in. Note that on this one, x to the 4th times y minus 2. Anytime y is 2, 2 minus 2, I'd get 0. So all of these are going to be 0. When x is 0, it'll also be 0. So that's nice. Now I can plug in some other points. When x is 1, when x is 1 and y is 0, so on A, when we have 1 comma 0, we'd have 1 times negative 2, that'd be a negative 2. 1, 1 would be negative 1. 1 and 3 would be a 1. Okay, I'm also going to check. Negative 1, 0, whoops, 0. Negative 1 to the 4th would be a positive 1, so that's also negative 2. Negative 1, 1 would be a negative 1. Negative 1, 3 would be a positive 1. Okay, so these are positive ones. These are negative ones. And these are negative 2s. So they're going to be steeper. While the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are negative. Notice that x to the 4th is always going to be positive, so I would note that. X to the 4th is always positive. Y minus 2 is less than 0 when y is less than 2. So the slopes are negative. When y is less than 2 and x is not 0. Note, if x is 0, we're going to have a slope of 0. Then it says find the particular solution if we know that f of 0 equals 0. Okay, so dy dx equals x to the 4th of y minus 2. Alright, so we got to separate our variables. I'm going to move the y minus 2 to the y, move the dx with the x. So I get dy over y minus 2 equals x to the 4th dx. Over y minus 2, that's a natural log. And this would be 1/5 x to the 5th plus c. Now I know f of 0 equals 0. So I need to solve this. First of all, I need to solve for y. That would be e to the, so absolute value y minus 2 equals e to the 1/5 x to the 5th plus c that just turns into kind of a coefficient over here. When x is 0, y is 0. So remember, we have two options here. It's either positive or negative. So either y minus 2 equals positive or y minus 2 equals negative. Oh, plus 2. And if I plug in 0, this becomes a 1. So I'd have c plus 2 is 1. So either way, this c, I'd either make it a negative 2 or I'd make it a positive 2. I'd have to make that be negative 2 e to the 1/5 x to the 5th plus 2 to make it where f of 0 equals 0. And now's when I'll call it an f of x. Next one, sketch a slope field. Okay, so y minus 1 over x squared. All right. So negative 1, 2, negative 1, 1, negative 1, 0. If I plug in negative 1, I get a positive 1 in the bottom. And then I get a positive 1 up top, so I get a 1. Positive 1, get a 0. 1, get a negative 1. Okay, so if I plug in 0 for x equals 0 would be undefined. Okay, so that's good to know. When I plug in a positive 1, I'm going to get the same as these. So I need to check the 2's. 2 would be 4 in the bottom and a 1 up top, so that's 1/4. 2 comma 1 would be 4 in the bottom and a 0 on top. 2 comma 0 would be a 4 in the bottom and a negative 1 up top. Okay. So when x is 0, I'm undefined. So those would be vertical lines. Negative 1, 2 is a positive 1, 0, negative 1. I would have the same exact thing for positive 1. Now for 2, up 1 over 1, 2, 3, 4. It's going to be a very slanted line like that. And then we'd have a negative 1 that kind of mirrors it on the bottom. Find the particular solution if f of 2 equals 0. Okay, so dy dx equals y minus 1 over x squared dy over y minus 1 equals, this would be 1 over x squared dx natural log of y minus 1 negative x to the negative 1 sorry, I paused it for a second and I moved my paper. Okay, so I'm solving for c. Get minus 1 equals c e to the negative 1/2. I'm solving for c, sorry about that. So I'm going to divide by e to the negative 1/2. That's going to make it a negative e to the positive 1/2 equals c. Now remember, c could have been negative or positive. It didn't really matter. It ends up being how it is. So that works out great. So my function ends up being negative e to the 1/2 e to the negative 1x plus 1. Well, that's actually, whoops, I forgot the equals. Kind of nice to be 1 minus e to the 1/2 minus 1 over x. That's actually kind of nifty. Now part C says, for the particular solution described in part B, find the limit as x approaches infinity. So what happens as x approaches infinity here? Well, this becomes a 0, right? So in part C, the limit as x approaches infinity of 1 minus e to the 1/2 minus 1 over x. This, this would approach 0. So it's basically 1 minus e to the 1/2.